Hey guys, so far we have looked at a couple of activities in this chapter regarding acids, mostly ones with a base also. Today we will be looking at one more activity that involves an acid and with something else, right? Another type of chemical compound. Okay, so since it's an activity again, I'd request you to please use the experiment format to make sure you're noting down everything in the right format. Okay, so for today's activity, we are going to be using an acid to look at something called a metal oxide. Okay, how a metal oxide can interact with an acid. Now, metal oxides are actually commonly found in nature, right? So we notice whenever we have something made of iron or a metal, you'll see that after a while, if you just keep it out in the open, couple days, weeks, months later, it starts to rust, right? Especially iron will rust. Different metals have different types of oxidation. For iron, it is called as rusting. So we know that this rust, whatever it is actually oxide. Okay, so what happens is the oxygen in the air will react with the metal and it will form a compound metal and oxygen, metal oxide, as simple as that. So the reason why metal oxides are bad is because it damages the metal, right? If we have like an iron railing or a gate, if it gets rusted, it's pointless, right? It starts to break and all that. So this is why to prevent rusting and all, we use paints or we cover it with other things, maybe with plastic or with another metal. There are a lot of ways we can remove or prevent rust. From forming. Today what we will do, we are going to look at if I use this rust or this metal oxide and add it to an acid, what will happen? Okay, will they even interact or not? So that is our aim for today, to observe the reaction between an acid and a metal oxide. Right, so we have a container with our acid and we have, since I told you that rust is a metal oxide, right? I have simply taken a rusted piece of metal, that this is a screw that has been out for some time and that has gotten rusted, right? So this will be our equipment or materials required for this thing. For the procedure, it's quite simple. Let's just see. I am going to make sure that this piece of metal touches this acid inside this beaker. Again, precaution, because it is an acid, we have to be very careful when handling an acid, right? So, procedure, I'll first pour the acid into this beaker, which I've already done. The next step, what I will do, I will make sure this is touching the acid. So I want you to observe carefully what happens when this piece of metal will touch this acid. Okay. Right, it might take some time, but it eventually happens. Right, you'll start to see that there are like bubbles formed on the surface of my screw. Right now, that's all I can see. Right. So I'm not sure if you'll be able to see, but there are like bubbles on the surface of this object right now. tiny little bubbles. Okay, so I'll just give this reaction some more time. Leave it here. There's definitely some change happening that I'm going to try to show it to the camera. I'm not very sure if you'll be able to see, maybe from the bottom, right? Forgive me if you are not able to see, but there are really minute changes happening to the screw. Okay, the screw will look bent, it actually isn't bent, that is refraction, some other topic that we'll learn about. For now, let's just focus on this reaction. Right, now so now I'm going to start to notice something right here. I think it's about done, so let me just show you. Let's just take a look at this acid now. All right, now I want you to observe this nail very carefully. You'll see that there are parts of it that have become white now. Right, you will see that there are certain parts of the nail that have kind of cleaned up in a way, even in a manner of speaking. So you see the middle of this head has become white, even the bottom of this head has kind of started, there's like white dots all over, right? It means some reaction has occurred over here. And there is a slight change in color of my solution. If you notice, it's like mildly yellow, very mild, barely noticeable, right? It's mildly greenish yellow, right? If I keep this in here longer, it might actually even get like more dark, or the reaction might complete to a longer extent. I will leave it here for the time being, and meanwhile let's discuss what exactly are we seeing here. Okay, so what we are looking at right now, whenever a metal oxide reacts with an acid, that metal oxide becomes a salt. Okay, so what we are getting here right now is the oxide changes into a salt of some form along with water. Okay, if you remember, whenever we even do a metal and acid reaction, we'll see that hydrogen gas, salt and water are the general products, right? And over here, similarly, without the hydrogen gas, we simply have a salt solution along with the water. Also similar to a base and a water, right? If you remember, base and acid will give me salt and water. It's more comparable to that. Same products here. You'll get a salt, you'll get a water. The salt will depend on which metal oxide I'm using. Since this is iron, I'll say some iron salt is being formed, iron chloride in this case. Okay. If I use a different acid also, the salt will change. So for my reactants, I'll write metal oxide and acid gives rise to products which is salt and water. All right. Now, since it is a salt which is mixed in water, we'll call it an aqueous solution, right? If you're familiar with that word, we have discussed what is an aqueous solution. So now I'll show you the nail again. I try to give it a little more time. It's a little more cleaner, right? Do you notice it? It was like really fully dark rusted, and now look at the head. Most of it has those white spots that are clearing up. The solution has become a bit more greenish yellow, right? So this is our reaction, metal oxide with acid is going to give me salt and water. All right. So that's it for today, a very simple reaction. For tomorrow we'll look at a different topic altogether. I hope you were able to follow the class, and I'll see you in the next class. Okay, thank you.